Alright, so here in this video we're going to look at the alkenes. Alright, so the alkene is a family or a homologous series of unsaturated hydrocarbons with a general molecular formula of Cn H2n. Alright, again, alkene is a homologous series or a family of unsaturated hydrocarbons with a general molecular formula of Cn H2n. So what are unsaturated hydrocarbons? Unsaturated hydrocarbons are hydrocarbons with carbon-to-carbon double bond. Alright, so the reason why they are unsaturated is because they contain carbon-to-carbon what? Double bond. Then they are hydrocarbons because they are compounds that are made up of carbon and hydrogen only. Alright, so again, the alkene is a homologous series or a family of unsaturated hydrocarbons with the general molecular formula of Cn H2n. So this is the general molecular formula for what? The alkene. It is very important for you to know that the alkenes are also called olefins. So another name for alkenes is what? Oleffins. Very important. Then all the members of the alkene, all the members in this homologous series, they end with ene. For example, ethene. Alright, it ends with ene. Propene, which is the third member, it ends with ene. Butene, which is the fourth member, it ends with what? ene. So all the members of the alkene series, they end with what? ene. So it's very important also to note that the alkenes are chemically more reactive than alkanes because of the availability of electrons in the double bond. So this is a typical exam question. You can be asked, why are the alkenes chemically more reactive than alkanes? So the alkene are chemically more reactive than alkanes because of the fact that they have electrons in what? The double bond. Or you can simply say alkenes are chemically more reactive than alkanes because of the presence of the double bond. Alright, that is why they are chemically more reactive than alkanes. Again, why are the alkenes more reactive than alkanes? Alkenes are more reactive than alkanes because of the availability of electrons in the double bond, or because of the fact that they are unsaturated hydrocarbons. Alright, so since they are more reactive than the alkenes, some of the reactions that the alkene can undergo include combustion reaction, substitution reaction, addition reaction, oxidation reaction, and polymerization reaction. These are some of the reactions that the alkenes can undergo. Alright, for the alkanes, which are less reactive, the two main reactions that they undergo is just combustion reaction and substitution reaction. But the alkenes undergo all these reactions. Then also it's important to note that they exhibit both structural and geometric isomerism. Alright, the alkenes exhibit both structural and geometric isomerism. The alkanes exhibit only structural, they only exhibit structural isomerism. Alright, they only exhibit structural isomerism. The alkenes exhibit both structural and geometric isomerism. So this is one of the difference between the alkenes and the alkane. Very important. So again, alkenes is a homologous series or a family of unsaturated hydrocarbons with general molecular formula of Cn H2n. So this is very important. This is their general molecular formula, Cn H2n. The alkenes are also known as what? Oleffins. They are also called oleffins. Alright. Alkenes are chemically more reactive than alkenes because of the availability of electrons in the double bond, or because of the fact that they are unsaturated hydrocarbons. Alright. So having known all this, the next thing that we're going to look at is the laboratory preparation of ethene, and we'll continue with this in our next video.